So we're going to practice counting to 18 electrons using this complex, bromohexacarbonylmanganese 1. So we're going to use both methods, both the oxidation state method and the neutral ligand method. So let's start with the oxidation state method. In this method, we consider that the bromine has a negative charge, so that's going to make this manganese 1. And manganese 1, if we look at the periodic table, manganese is in group 7. We're going to subtract 1 electron for the charge, so it'll have 6 electrons. We have 5 carbonyl ligands, and so each of those will count as 2 electrons. And we have 1 bromide ligand, and so it will also count 2 electrons. So that's going to give us 6 plus 10 plus 2 equals a total of 18 electrons. In the neutral ligand model, we're going to go through a similar process. So we're going to think about manganese, but we don't care what its oxidation state is. Instead, we're going to say manganese is in group 7, so it has 7 electrons. And we have 5 carbonyl ligands, which are an L-type ligand. And L-type ligands donate 2 electrons. And so we have 5 of them. So that's going to give us a total of 10 electrons. Finally, we have bromine, which is an X-type ligand. And so that bromine is only going to count as a 1 electron donor. So in this case, we get 7 plus 10 plus 1 electrons equals 18. So we get the same number of electrons in both cases, but we think about how they're distributed a little bit differently. And a lot of that is related to how we think about anionic ligands. So in the case of the oxidation state, we are assigning both of the electrons in the manganese-bromine bond. If you sort of imagined 2 electrons here, we're assigning them both to bromine. So that's going to make bromide with a complete octet of 8 electrons. And that's going to make the manganese electron deficient, so it's going to have a +1 charge. On the other hand, in the neutral ligand method, we're imagining that the manganese and the bromine split the electrons equally. And so 1 electron goes to manganese and the other one goes to bromine. So we end up with manganese in its neutral atom form. So it's neutral, which means it has 7 electrons, and we end up with bromine being neutral. And so it also has 7 electrons. And we see that one of the electrons is not paired, and it's that unpaired electron that bromine is going to use to bond with manganese. So in this, we have these 2 different methods. For the most part, they both produce the same result, but they count. We have both so that we can think about the many facets, the continuum between ionic and covalent bonding that these organometallic complexes represent.